Now we'll study some standard characteristics of stationary waves in a region. Very first point we already studied, that is no net energy flow take place in any direction. We already discussed that when equal amplitude waves traveling in opposite directions superpose, no net energy flow take place as the two waves have equal power. Now the second point is related with the oscillation of medium particles, for which we can say all particles between two successive nodes oscillate in same phase. This is an important point you need to keep in mind, like just in the previous section we have studied about stationary waves when established in a string. The situation is like this, that the string oscillates up and down, or we can say if it is oscillating in two loops, so we can say all medium particles which are between two successive nodes, when the string is in upper position, the side string will be in lower position, and we can say when this is coming down, other part of a string will be going up in this manner, and finally the string will occupy the dotted position which I have drawn here, and then it will come down, it will move up. So in this manner the medium particles will oscillate when stationary waves are produced. So here we can say all particles which are between these two nodes are oscillating parallel to each other, or we can say all particles which are in the adjoining loops also oscillating parallel to each other. So all particles between two successive nodes oscillate in same phase, and as the separation between the two nodes is lambda by 2, this is the length of one loop produced in the stationary wave. This is also termed as loop length. So in one loop length all particles oscillate in same phase. Similar to this, another point we can define, that all particles on one side of a node in a loop oscillate in opposite phase with those particles, with those on the other side of node in a loop. Here we can say, if we talk about this node, all those particles which are on the left side of this node in a loop, if these are coming down, we can see in this duration all the particles which are on the other side of the node are going up. Exactly the oscillation of these particles and these particles are anti-parallel with each other, or we can say the phase difference between these two oscillations is always pi, or these two loops all particles will oscillate in opposite phase. The last point about the standard characteristic, we can say that during one oscillation of stationary wave, all medium particles come in form of a uniform straight line twice. During one oscillation, we know that a particle crosses mean position twice. So when this part of a string will be straight, or when all particles are crossing their mean position, other parts will also be crossing their mean position, or we can say all the medium particles in the string will form a straight line, and after half oscillation again this will form a straight line. So we can say during one oscillation twice, all the medium particles will be in form of a uniform straight line. So be careful about these four characteristics, as many various applications we'll discuss based on these points.